So let us have a look at the surface distributions. First, the surface distribution of temperature. We call it SST, sea surface temperature. Okay, here's the SST distribution. And if you look at it, so that's you can see indeed it's warm near the equator, and it's cold. The water is cold near the pole. Okay, so what determines the surface temperature is, so the main reason for this distribution is the air-sea heat flux. So it's the distribution of the air-sea heat flux. Okay, some regions are warmed up and other regions are cooled down due to that, and that sort of sets up the temperature difference between the equator and polar regions. However, there are some additional features. For example, the regions where you have a relatively swift horizontal currents, we know them as western boundary currents, modifies the sea surface temperature distribution. So in particular, on the western side of oceanic basins, if you look carefully, you can see some modification of the temperature structure. On the other hand, you can also have a modification of the sea surface temperature by upwelling of colder water to the sea surface. Okay, let me just look with the mouse. Okay, with the mouse here, we are in the Pacific Ocean, and if we look in the northern hemisphere on the right, where the mouse is here, you can see that there is this water. If you just move along the same line of the same latitude, you can see it gets colder. Okay, this one is the Californian upwelling system. You can see some other regions too. What you also can identify, and that plays a very important role in the distribution of rainfall in the oceans, and also creates tropical cyclones. So is the so-called warm pool. Okay, it's the regions where you have water temperatures above 27, 28 degrees, and you can see an extensive warm water pool in the western Pacific tropical equatorial region, also including the eastern tropical Indian Ocean. This is the so-called warm pool.